Section 7. Noble gases as the key to chemical behavior. Chem Talk, the noble gases, the discovery of argon. Imagine that you prepared 2 samples of nitrogen, each 1 liter in volume. You found one to have a mass of 1.250 grams and the other a mass of 1.257 grams. You might be tempted to attribute the difference to experimental error. Lord Rayleigh did not. In 1892, he decomposed ammonia to generate 1 liter of nitrogen with a mass of 1.250 grams. In another preparation method, he isolated 1 liter of nitrogen with a mass of 1.257 grams by removing what he thought were all the other gases from a sample of air. What accounted for the difference in masses of the 2 samples? Could there be yet another gas in the air that Rayleigh didn't know about? William Ramsay, a colleague of Rayleigh, looked to the experiments conducted by Henry Cavendish 100 years earlier. Henry Cavendish, the discoverer of hydrogen, had been puzzled by a small bubble of gas remaining after he had chemically absorbed all of a sample of nitrogen he had similarly extracted from the atmosphere. As Cavendish had done, Ramsay extracted a sample of nitrogen from the atmosphere and then chemically absorbed all of the nitrogen in that sample. He looked at the spectrum of the remaining bubble of gas, just as you have looked at the spectra of various gases in section 4 and 5. The new spectral lines of color he saw showed him that the bubble of gas was a new element, which today is called argon. It had previously escaped notice because of its rarity and lack of chemical activity. A new family. When Mendeleev formulated the first periodic table, argon had not been discovered, and therefore it had not been placed in the periodic table. There was no obvious place for argon, so a new column was created. A prediction was made that there would be other elements with similar properties to argon. The other elements of this family were subsequently discovered by the end of the 19th century. Good scientific theories are able to predict things that nobody is aware of at the time. When people perform additional observations, they then discover these predicted things with the very properties that were described. This one means by which the value of a theory can be judged. Unlike atoms of the other chemical elements, atoms of elements in this column are so stable that they either do not react at all or they react only in unusual circumstances with other elements. For this reason, this family has been known as rare gases because they are rare in abundance, inert gases because they are not very reactive, or noble gases. Valence electrons. The energy level of an electron is important. The greater the number, the larger is the average distance between the electron and the nucleus. The electrons in the highest energy levels are usually farthest from the nucleus. The differences in the electrons in the outermost level identify an atom from its nearest noble gas. It is these electrons that are responsible for the chemical behavior of the atom. They are called valence electrons. The maximum number of valence electrons that you can have is 8 for the representative elements, 2 in the S and 6 in the P sublevels. A simple way to determine the number of valence electrons for the representative elements is to look at the element's group number. All elements in group 1A have 1 valence electron. All elements in group 2A have 2 valence electrons. Those in 3A have 3 valence electrons, and so on. The noble gases in group 8A all have 8 electrons in their outermost energy levels, with the exception of helium. Helium only has 2 electrons.